Okay, and next we have interference from thin film. What is a thin film? First I will define a thin film. If we have a layer of extremely small thickness of certain transparent medium is called thin film. Like if we have a soap bubble, if sunlight is shining on that soap bubble, then we have different colors. We can see different colors. If we have oil silk which is illuminated by sunlight, then we can see different colors on this oil silk. This is because of interference of light waves, which is reflecting from both the top as well as from the bottom surface, like from the front face as well as from the back face of this thin film. Now here I will consider the interference from a thin film. Let's suppose we have a thin film, a soap bubble. You can say that I can write a little bit more bigger. Let's suppose we have a thin film. This is a thin film. This thickness D, which I call, let's say I call it L, which is much smaller. I can say that L is approximately equal to 0. Like if we consider soap bubble, then the thickness of the soap bubble is very small. So the thickness is approximately equal to 0. Now this is a thin film with thickness L, and let's suppose we have a ray of light incident on this thin film at point A. Let this is point A. Now above this thin film we have ear here. In this space we have ear. Here we have also ear. This is either a thin film of soap or thin film of oil. Now the refractive index of this film, this region is, let's say, N2. Now this is ear, I call it, its refractive index is N1, and this is also ear, I call it N1. Now let's suppose we have a ray of light incident on this thin film at point A. Now, and let's suppose this is a wavelength, this ray has a wavelength lambda. Now this ray falls on this thin film at point A. After falling on this thin film, this ray, a part of this ray is reflected back in such a way, this is the reflected ray R1. In such a way, if this is the normal to this surface, then the angle of incident, this is theta E and this is theta F. Angle of incident and angle of reflection, theta A and theta R, they are equal. Now this ray R1 reflected in this way, and here we have someone which is observing this rays. So this is the observation I. Now this incident ray, which is represented by I, intercept at the front face of this film at point A, and here two things happen: the reflection of light as well as the refraction of light. Now here we have this ray reflected back, and a part of this ray is refracted. This is refracted ray. Now the reflected ray R1 is intercepted by this observer I. Here this is the observer I. The refracted ray, this refracted ray crosses the film. It crosses the film and reaches to point B, where at point B again either this ray reflected back or it is refracted to the ear at the bottom surface. Now this reflected ray crosses the thin film again and reaches to point C. Here at point C again we have two things: either this ray reflected or it can be refracted. Now the refracted ray here, this is the observer eye. Observer eye, which is intercepted by this observer eye. Now we have two rays now. This is ray 1 and this is ray 2, R2. Now ray 1 comes from the reflection from the top surface, and ray 2 comes after traveling a twice distance. Like first it will move from A to B and then from B to C, and after that it goes to the observer eye. So there is a path difference, like the path of this ray is this one and the path of this ray is this and up to this one. Now if the path difference between this ray 1 and ray 2, if path difference is an integral multiple of wavelength m lambda, then we have a constructive interference. So if there is a constructive interference, then the part of the thin film like AC, part of the thin film AC, this region looks bright. On the other hand, if the path difference between this ray 1 and ray 2, path difference between ray 1 and ray 2 is odd multiple of lambda by 2, like 2m plus 1 lambda by 2, then we have destructive interference. And if there is a destructive interference, then this part of the film AC, which looks dark, even it is illuminated by light. So this is called interference from thin film. So the main point is we have incident ray which strike the top surface of this film at point A, where this ray is either reflected or refracted. The reflected ray R1 goes to the observer eye, while the refracted ray, this is the refracted ray. It crosses the thin film and reaches to point B. At point B again we have a surface, the bottom surface of the thin film. So here this ray is reflected or refracted. The reflected ray crosses the thin film and reaches to point C. So again here we have a surface, the top surface. So again there are either reflection or refraction. The reflected ray goes back while the refracted ray crosses the film, upper surface of the thin film, and goes to the observer eye. Now these two rays on their way superimpose on each other, and they superimpose in such a way that if the path difference between these two rays is m lambda, integral multiple of wavelength, then these two rays will interfere constructively, and once they interfere constructively, then the region of the film AC will look bright. Now if the path difference between these two rays R1 and R2 is odd multiple of lambda by 2, then what will happen? These two rays, they interfere destructively, and once they interfere destructively, then the part of the film which is illuminated by the sunlight looks dark. So this is all about interference from thin film. Thank you.